Hello viewers, welcome back to my YouTube channel. In this video, you will be learning about what is an arithmetic progression. An arithmetic progression is a list of numbers that follows a certain pattern. The pattern is any term in the given sequence is obtained by adding a fixed number d to its preceding term except the first term. So the list of number that follows this pattern is called the arithmetic progression. Here the first term is a and the common difference is d, and n is the number of terms, and the general term is connected by the nth term. A and d are connected by the relation an equal to a plus n minus 1 into d. This is the general relation between the common difference d and the first term a and the nth term. So if you want to find any term in the given sequence, let's say you want to find some 20th term giving n equal to 20 in this relation, we will be able to find what is the 20th term in the given sequence. So this is the relation an equal to a plus n minus 1 into d. And the second formula is for finding the sum of the first n terms of an AP. So if you identify the given sequence is an arithmetic sequence, then if you want to sum up the first n terms, then we can use this formula s equal to n by 2 into 2a plus n minus 1 into d. So if you know a, d, first term a and the common difference d and the total number of terms in the given sequence, then we can apply this formula. And here we denote the last term as L. Okay. So if you know the first term and the last term and the total number of terms, and we have a simple formula to find the sum of first n terms, that is s equal to n by 2 into a plus l. That is if the given sequence is a finite sequence, s equal to a by n by 2, s equal to n by 2 into a plus n. Okay. So to get in-depth knowledge about arithmetic progression, we will solve some important problems under AP. So here the first problem is, which term of the progression minus 1, minus 3, minus 5 is minus 39. Here the question is, what is the n associated with this minus 39? Which term is minus 39? So we need to find what is the n related to minus 39. Now let's solve this. From the given sequence, the first term a is minus 1 and the difference, common difference is, you can find the common difference by subtracting the any term by its preceding term. So here you can find minus 3 minus of minus 1. This is d can be found by tn minus tn minus 1. Any term, the difference of any term from its preceding term. So d is minus 3 plus 1, which is minus 2. So we know a and d. A is minus 1 and d is minus 2. And here what is given? Minus 39. What is the n associated with minus 39? So if an is minus 39, what is n? We need to find what is n. We know that an equal to a plus n minus 1 into d. So it is which is minus 1 plus n, we have to find n minus 1 into minus 2. an is minus 39. We are finding the minus 39th term. What is minus 39 associated with n? Simplifying this, we will get minus 39 equal to minus 1 minus 2n plus 2. Simplifying, we get 2n equal to 40. So from this n is equal to 20. So minus 39 is the 20th term for the given progression. It is the 20th term. We got n is equal to 20. So in the given progression, minus 39 is the 20th term. This is very simple. So first we have to find what is A, what is D, and here minus 39 is the term, and we are finding the n associated with that. We are applying the relation an equal to a plus n minus 1 into d. Similarly, the next one, find the 20th term of the progression. What is the 20th term in the given progression? This is very simple. As we did before, this is, we need to find what is the 20th term. We need to find what is A20. Here A equal to 1, and what is D? D is T2 minus T1 or T3 minus T2. 4 minus 1, which is 3. Apply this general formula an equal to a plus n minus 1 into d, a equal to 1 plus, here n is 20, we are finding the 20th term. So 20 minus 1 into 3, a20, we are finding the 20th term. So it is 1 plus 19 multiplied with 3, 1 plus 57, which is 58. Therefore, the 20th term is 58. And find the last term of the series, 5, 7, 9, etc. to 21 terms. So, totally there are 21 terms in the given series. We need to find the last term. The last term is nothing but the 21st term. Okay. So, how to find the 21st term? We have to find what is A21. Okay. So, here A equal to 5 and D equal to 2. 7 minus 5 or 9 minus 7. Okay. It is 2. So, as we did before, totally there are 21 terms in the 21 terms are there in the given series. We have to find the last term. The last term is nothing but the 21st term. So, an equal to a plus n minus 1 into d. In the general formula, we are substituting a21 is nothing but the last term. Last term always we represent it as L, which is equal to 5 plus 21 minus 1 is 20 multiplied with 2. So, which is 45. 45. Now, we move to the next one. Find the sum of the series. The series is 951 to 100 terms. Okay, so totally there are 100 terms in the given series. We have to find the sum of the given series. Okay, so here what is the first term? A is 9 and the difference D is T2 minus T1, 5 minus 9, which is minus 4. Here the series is a decreasing series. So, A equal to 9, D is minus 4. Here the last term is unknown. Okay, so there are totally 100 terms. Okay, so the formula that is suitable to apply here is Sn equal to n by 2, 2a plus n minus 1 into d. This is the suitable formula that we can apply here. So, 100, n is 100. Totally how many terms are there? 100 terms. 100 upon 2 plus 2 into a. I directly substitute. A is 9. 2 into 9 is 18 plus n is 100. 100 minus 1 is 99 multiplied with minus 4. I am cancelling this. So, I get 50 18 minus 396. 396. So 50, 18 minus 396 is minus 378. The answer could be minus 18900. Okay. So this is the sum of the series to 100 terms. Okay. Now we do the next one. The sum of three integers in AP is 15 and their product is 80. Find the integers. Three integers are in arithmetic progression. Their sum is 15 and their product is 80. We need to find the integers. Now for the solution, let us assume the integers as, since they are in AP, the integers are a minus d, a plus d. Since they are in AP, you can assume the integers as in this form. Now their sum is 15 and their product is 80. Okay. So adding all the integers, a minus d plus a plus d, 15. Okay. So here d will get cancelled. 3a equal to 15. From this, what is a? A is 15 upon 3, 5. You can find what is a from the first condition. And what is the second condition? The product of the integers is 80. So we take the product a minus d into a plus d equal to 80. Here we consider a minus d and a plus d, and you can rewrite it as a square minus d square. A plus b into a minus b is a square minus d square into a equal to 80. Just we got what is a. A is 5. Substitute here. So a square becomes 25 minus d square into 5 equal to 80. You can cancel 80. This goes 16 times. So we need d square. 25 minus d square equal to 16. So from this, d square equal to 25 minus 16. D square is 9. So d is plus or minus 3. So we got a and d. Now we can find the integers. What are the integers? Therefore, the integers are a equal to 5. If a equal to 5 and d equal to 3, the integers are, substitute a minus d, a, they are in the form we have considered in the beginning. The integers are in the form a minus a plus d. A minus d, a plus d. Substituting over there, we get 2, 5, 8. So if a equal to 5 and d equal to 3. If we assume a as 5 and d as minus 3, we get the integers in the reverse order. Okay. So the integers are, in this case, the integers are just in the reverse order, 8, 5, 2. Okay. Both are same. The sequence are same, but it is in the reverse order. So we got the integers for the given question, the 3 integers. Now let's move to the next one. The first and the last term of an AP are minus 4 and 146. The sum of the terms is 7171. Find the number of terms. So here we have to find what is the total number of terms in the given sequence. Here what is mentioned from the question, the first term is minus 4 and the last term we always represent it as L. Last term is 146 and sum of the terms, that is Sn, sum of the terms is 7171. We have to find what is the number of terms, total number of terms in the given sequence. Okay, so we have a suitable formula for this, that is Sn equal to n by 2 into a plus n. Okay, so we can apply this formula to find what is n, total number of terms. Okay, so here Sn is 7171, n is unknown and a is minus 4 and the last term is 146. 146 minus 4 is 142. Okay, cancelling by 2 we get it is 71. So n equal to 7171 upon 71, which is 101. So the total number of terms in the given sequence is 101 terms. There are totally 101 terms in the given sequence. Here the first term and the last term is given and the sum of the terms is mentioned. Okay, so we can apply this suitable formula to find what is the unknown n. We move to the next one. The sum of a certain number of terms of an AP series minus 8, minus 6, minus 4, etc. is 52. Find the number of terms. So here also, as we did before, we can solve this problem. This is the sum. The sum is 52. Okay. So here the last term is not known. Okay. Only the first term is given and difference is known. Right. So from the progression we can write what is the first term. It is minus 8 and D is minus 6 minus of minus 8, which is 2. Okay. T2 minus T1, D is 2. So here the suitable formula that we have to assume is Sn equal to, we have to find the total number of terms. Number of terms. So here what is the sum of the progression? 52. Okay. The suitable formula is Sn equal to n by 2 2a plus n minus 1 into d, because here a and d are given. From the progression we can get what are a and d. Okay, so we have to apply this formula. So from this substitute Sn, the sum of the progression is 52. 52 equal to n is unknown, n by 2, 2 times of a is minus 8 minus 16 plus n minus 1 multiplied with d, that is 2. Okay. Now simplifying this, we get taking 2 to the left side, we get 104, which is equal to minus 16n plus 2n into n minus 1. Further simplifying, we get 2n square minus 16n minus 2n equal to 104. Cancelling by simplifying again, we get minus 18n minus 104 equal to 0. Dividing throughout by 2, we get n square minus 9n minus 52 equal to 0. Now solving this, minus 52 3 times minus 14 becomes minus 9. So the factors are n plus 3, n Here minus 52, we will have minus 13 times 4. Minus 13 times 4. So it is n solving this, we get n minus 13 into n plus 4 equal to 0. So n equal to 13 and minus 4. N is nothing but the total number of terms. It could not be negative. So we consider the positive 13. Okay. So n is equal to 13. So the total number of terms in the given series is 13. We have two values for n. One is positive, another one is negative. This is the number of terms. So minus 4, n equal to minus 4 is not admissible. So we take n is equal to 13. Now the next one is the first and the last terms of an AP are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? So what is given? The first term and the last term. Okay. So which is the first term? 17 and the last term is 350. D, difference is given 9. Okay. So we have to find how many terms are there. What is n and what is their sum? Sn. Okay. Now here 350 is the last term. Okay. So using this we can find how many terms are there. Okay. Using the general formula, that is we know that an equal to a plus n minus 1 into d. Okay. So 350 is the last term. So what is the n associated with that? 350. Okay. So 350 equal to a is 17 plus we are finding n minus 1 into 9. Okay. 17 taking to the next side, we get 9 times of n minus 1 equal to 333. So from this 9n equal to 333 plus 9. 9n equal to 342. So n is 342 upon 9, 38. Okay. So the total number of terms in the given sequence is 38. So we use the general formula. We consider 350 is the last term and what is the n associated with that 350. We got n is 38. Now we need to find in the same question what is their sum. So for finding the sum, you can use Sn equal to n by 2 into a plus l, because the first term and the last term and the number of terms all are known. Okay, so Sn equal to n by 2 into a plus l. Okay, substituting here n is 38 by 2 and a is 17 and the last term is 350. Simplifying this, we will get Sn as this goes 19 times, 19 into 367, which is 6973. 6973 is the sum of the sequence. And the next question is find the sum of first 22 terms of an AP in which d equal to 7 and the 22nd term is 149. We have to find the sum of first 22 terms. First 22 terms. So what is the 22nd term? 149. Now to solve this problem, what is given? D is given. D is 7 and the 22nd term is 149. The first term is not mentioned, so we have to find the first term. We have to find the sum of first 22 terms, that is S22. We need to find what is S22. So first we will find what is A. Okay. Now how to find what is A? The 22nd term is 149. So using the general formula an equal to a plus n minus 1 into d, we can find what is A. Okay. Here the 22nd term is 149. Okay. So A22, put n is equal to 22. A is not known. N is 22. 22 minus 1 is 21 into 7. A22 is 149, which is equal to A plus 147. From this we will find what is A, which is 149 minus 147 is 2. So A equal to 2. So we know what is A, what is D and the total number of terms. We are finding the sum of first 22 terms. So the suitable formula is Sn equal to n by 2 into 2a plus n minus 1 into d. So we have done so many times using this formula and substituting all the things. Finally, you would get S22 as 1661. After substituting all the values a, d, n, everything, you will get S22 as 1661. I left this work to you. This is very simple. Substitute all the values a, d and n is 22. You will get S22 as 1661. Now the next is find the sum of first 15 multiples of 8. First 15 multiples of 8. So let's form the sequence. What are the values that are multiples of 8? First 15 multiples of 8. So the sequence is 8, 16, 24. Totally there are 15 terms up to 120. So this is the sequence. There are 15 terms in this given sequence. We have to find the sum of that. So here what is A? A is 8 and the last term is 120 and totally 15 terms. N is 15. N equal to 15. 15 terms are there. So you can apply this formula Sn equal to n by 2 into a plus l. So n is 15. A plus 120. Simplifying, you will get the sum of 15 terms which are multiples of 8 as, simplifying the above, you will get it as 960. One more similar problem of the previous kind. Find the sum of first 40 positive integers divisible by 6. So totally there are 40 positive integers which are divisible by 6. Now let's frame the sequence. The sequence is 6, 12, 18. It goes like that. 240. Now follow the same steps. A equal to 6, L equal to 240 and totally there are 40 positive integers. Apply the same formula Sn equal to n by 2 into a plus l. Substituting all the values, you will get S40, that is the sum of 40 positive integers divisible by 6. That would be 4920. The simplification is very simple. Substitute all the values, you will get this answer. we have one final question. Find the sum of first 51 terms of an AP whose second and third terms are 14 and 18 respectively. Okay, we have to find the sum of first 51 terms. 51 terms, that is S51. We need to find what is S51. Here AD, nothing is mentioned. What is given? Whose second and third terms, that is A2. A2 is 14 and the third term A3 is 18. Okay. Now using this we can find what is A and D by using the general formula AN equal to A plus N minus 1 into D. A2 is 14. A2 equal to A plus 2 minus 1 is 1. D is not known. D. Okay, that is A plus D equal to 14. This is one equation. We can frame two equation using the above two condition. And similarly A3 equal to 18. A3 equal to, substituting in the general formula, A3 equal to A plus 3 minus 1 is 2, 2D. That is, what is A3? 18. A plus 2D equal to 18. This is the second equation. Now, solving the first and the second equation, we can find what is A and D. A and D are unknowns. We have two equations. Solving 1 and 2, you will find A as 10 and D as 4. So, we know what is A, what is D, and what we need to find? The sum of 51 terms, first 51 terms of an AP, that is S51. So what is the suitable formula? Sn equal to n by 2 into 2a plus n minus 1 into d. We have to find S51, substituting all the values. Here n is 51. We are finding the first 51, sum of first 51 terms. So S51 equal to 51 upon 2, 2a, that is 20, plus 51 minus 1 is 50 into 4. Simplifying this, you will get S51. The sum of first 51 terms of the AP is 5610. 5610. This video will help you to learn about what is arithmetic progression. This single video, from this single video, you will be able to understand what is an arithmetic progression, how to find the general term, how to find the sum of the given sequence, if the first term and the last term is known, and find the sum of the first n terms, everything. If you like my video, subscribe to my YouTube channel and please hit the like button if you like the video. Please share it with your friends. Thank you guys. Meet you all in the next video.